In this video, we are going to talk about work done and energy. Okay, what is work done? The work done in physics means when a force moves through a distance d, then the work done is force times the distance moved in that direction of the force. Now, the force is measured in a unit called Newton, and the distance is measured in meters. This is Newton times meter, which is Newton meters or joules. Now, the unit of work done is joules. This is named after a British scientist, James Prescott Joule. Now, we can define joule. We say when the 1 joule of work is done, when a force of 1 Newton moves through a distance of 1 meter. So if I make each of these as 1 Newton, 1 meter, that will be 1 joule. So 1 joule of work is done when a force of 1 Newton moves through a distance of 1 meter. Now, suppose we have a block of concrete resting on a rough ground, and somebody is pushing this block of concrete, and he pushes it through a distance of d meters. How much work is he doing? No, he's doing work against friction, right, in order to try to move this. So the force of friction is trying to stop it, but he is working against the force of friction. So work done is force multiplied by the distance. Now, if the force is 10 Newton, if he's exerting a force of 10 Newton, and he moves through a distance of 5 meters, the work done will be 10 Newton multiplied by the distance, which is 5 meters. 10 times 5 is 50 joules. Okay, so the work that he does is 50 joules. Now, next thing we're going to talk about is energy. What is energy? Now, energy is the ability to do work or the capacity to do work, and it's also measured in joule. Now, work done and energy are equivalent. Okay, they are the same thing. If work is done, then energy is used or energy can be stored. Or in order to do work, you've got to use energy. So the two are equivalent, okay, equal to each other. Now, we're going to talk about potential energy. Potential energy is the energy stored in an object. Now, it could be gravitational potential energy, or it could be elastic potential energy. Now, gravitational potential energy is due to the position of an object above the Earth's surface. Okay, the higher up it is, the greater the amount of potential energy it has stored. So if I move this object up, the higher I move it, the more it has potential energy in it, and the greater the ability for it to do work. So when I drop it, it will drop, and the energy changes to kinetic energy, which can change to work done. Now, Now, the other form of energy, potential energy, is elastic potential energy. Now, this is the energy in a stretched spring or in a stretched elastic band. Now, the example of that is like slingshot. When you put a stone in the slingshot and you pull the rubber bands back, that stores up energy. And when you let it go, all that energy changes to kinetic energy. So energy is stored in a spring or in an elastic band is known as the elastic potential energy. Now, the next thing that I want to move on to is Um, let's talk about the gravitational potential energy. Let me write the word gravitational. Potential energy. I'm going to use P for potential energy. Okay, we consider a mass M and you raise it to a height h. Now remember that's mass M. We use the small m. And we raise it to a height h against the force of gravity. Now, if this is m, then the force on this is due to the force of gravity. So we say that the force is the weight of the object, which is equal to mass times gravity. Now remember, mass times gravity. Gravity is 9.8 or approximately 10 newtons per kilogram. And if we raise it through a height h, then what you're doing is you're doing work. Now, work done in raising object. Okay, well, now remember, work done, the definition is force times distance. Is force multiplied by the distance. The force we are working against is the force of gravity. We are trying to lift the object against the force of gravity, which is m times g, times by the distance through which you move is the height h, is m times g times h. Now, what happens to all that work? All that work that we did in order to move the object. Now, where did the energy come from? If I'm moving this, I've got to have energy, right, in order to, well, that energy comes from the chemical energy of the food that I eat. Okay, so we move it up there to a height. So the amount of work is done is mg times h. Now, this work becomes stored up as potential energy. Now, once it's there, it has potential energy. It has the ability to do work, it's capable of doing work. Now, if I drop it, I can make it do work. So we say that the potential energy, or strictly speaking, gravitational potential energy is equal to mgh. Okay, so this is the formula for mass times gravity times height. Now we can use G is equal to 10 newtons per kilogram. You will see that in one of my previous videos when we talked about F equals mg. Now, suppose the force is 10 Newton. If the mass is 1 kilogram, if I'm lifting a mass of 1 kilogram, the force is going to be 1 times 10, which is 10 Newton. And a height of, say, 10 meter. If I raise it through a height of 10 meters, okay, how much potential energy is stored in this? So we say that the potential energy is equal to force, which is m times g times h. No, the mass is 1 kilogram, g is 10. So this is equal to 1 times 10 times by the height, which is 10 meter. 10 times 10 is 100 joules. So that means 100 joules of potential energy is stored in the object. The next thing that we're going to talk about is kinetic energy. I'm going to denote that with Ke. Now, kinetic energy of an object is due to the motion of an object, okay? How fast it's moving. Now, a bullet, for example, moves with a very, very high velocity, and therefore it has a lot of kinetic energy. It can penetrate a target, it can do a lot of work, and it has the ability to do work. It can penetrate a target, it can kill a person. Now, kinetic energy depends on the speed. The faster it's moving, the greater the kinetic energy. What about the mass? If the object was heavy or light, if it had a larger mass, will it have more kinetic energy? Yes. It also depends on how heavy it is. So it depends on the mass and the velocity. And in fact, the formula for this is half times the mass times velocity squared, half mv squared. Now, this is the formula for kinetic energy, is half mv squared, where m equals the mass and v is equal to the velocity. V is the velocity. Now, we're going to talk about different forms of energy. Now, there are different forms of energy. For example, we talked about potential energy, gravitational potential, elastic potential, and kinetic. These are the mechanical energies, but there are other forms of energy. You can have electrical energy, sound energy, heat energy, nuclear energy, okay? And we're going to list these first of all, we say potential energy, kinetic energy, elastic potential energy. These are the sort of mechanical energies. And then we also have chemical energy. Chemical, you have electrical, then we have heat, or thermal, we can call it heat or thermal energy. Sound is a form of energy. We talked about electrical, we can say magnetic energy, and we also have nuclear. 1, 2, 3, 4, 5, 6, 7, 8. Nuclear energy. Okay, these are the 9 forms of energy that we can have. Now, all these, like chemical energy is the energy that comes from chemical reactions, like in our body. Heat is produced due to chemical reactions. In a battery, the chemicals that they use and change to electrical energy, and so on. So we're going to discuss the conservation of energy, okay, and how these energies can change from one form into another in the next video.